A favorable wind is starting to blow in the West Pacific, and much more is forecast behind it. I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, April 2nd.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people. All the time, no hype.
Be sure and like and subscribe. Ring the bell. You get automatic notifications when the videos are posted, typically on Sunday evenings. And also, if you feel inclined, send $1 or $2 our way. We're trying to buy a new server. We're almost there, and this will help support our operations moving forward. Just click the special thanks button down below. And I'd like to take a moment to thank the folks that have donated this past week. Tom Keir, Rand Diego, Elliot Harris, Bones Jazz, Peter Belden, Petro Denel, Tokib, Spat Out Glory Film, Arturo Ayala. We really appreciate your contributions. It'll help us get to our goal and get us a little bit more bulletproof on our infrastructure. All right, let's get to work. We'll start by looking at significant wave heights for the North Pacific Ocean, and much like the past several weeks, there really isn't anything to mention. Little areas, seas maybe in the 10-foot range off of the Oregon coast, driven by northwest winds there, those winds pushing towards California, likely going to make for just a sloppy mess. Little low pressure off of Japan, but not really doing anything and not forecast to build anything. All right, let's get into it. We'll start by looking at current conditions in Northern California using the Point Reyes buoy, number 029, off of Point Reyes, California. We're looking at all the energy that's hitting that buoy, all the way up to 33.3 second period super long period energy, which there is none, whole way down to 5 second period. That'd be like pure wind chop. Ground swell typically starts around 13 seconds. So we see mainly a bunch of wind swell here in the each period band in about 2 feet or something like that, and not a whole lot else going on. Put that all together, primary swell is about 5.2 feet at 11 seconds from 317 degrees. That would theoretically make surf about a foot overhead, something like that. Then we go down to the northern end of Southern California, buoy 46053, East Santa Barbara. Again, same deal, only really no energy at all, just a little bump there at 5 seconds. Put that all together, primary swell 2.8 feet at 5.4 seconds from the west, 268 degrees. That theoretically makes surf about 1.5 foot. In the southern end of Southern California, we go to Point Loma South, buoy number 191. We see a little bit of energy here at 14 seconds or so. That is some leftover, very small southern hemi swell, early season swell. Primary swell, when you compute it all together, 1.4 feet at 13.9 seconds from 182 degrees. That puts surf at about 2 feet, and that's about what it is. And then we go out to Hawaii. No near shore buoys on the North Shore are operational, so we're out a ways off the coast. Buoy 5101 Northwest Hawaii, number 1. We see just wind swell in the 9 second period range, something like that. Primary swell 4 feet at 9.3 seconds from 79 degrees. Theoretically, that'd make surf about 3.5 feet. I'll say waist high, chest high, something like that. Maybe there are a few stray peaks like that, but still pretty quiet. We'll just take a quick look at significant wave heights over the North Pacific Ocean since Thursday, the 30th of March. Really nothing going on. The last little bits of a gale that created some weather in California was poised off the Southern California coast, quickly fell apart. On Friday, another little fetch developed here in the northern Gulf with seas in the 12-foot range or something like that, mainly just wind swell. And that continued on Saturday, pushing down the coast. And that gets us to about where we are now, with wind swell approaching from the northwest, and otherwise a pretty quiet pattern. So really no groundswell of any interest is poised for either Hawaii or California. So then we start looking to the future. We're going to look out a week. Anything beyond that, really not worth looking at. Yeah, the models go out 2 weeks, but if you follow them with any regularity, you realize anything after about 5 days almost never comes to pass. It's all a bunch of hype, and no point in getting yourself all worked up for something that won't happen. But things in the 5 to 7 day window, if they're projected on the model, the odds start increasing that those sort of weather systems will actually form. So start looking at the Jetstream today. These are winds up about 30,000 feet. They help support the formation of gales when those gales form, help direct their track. We're looking for a trough, a dip in the jet, and we see it right here. The jet is actually sort of split inland over Asia, comes together for the most part right off of Japan, digging out a little bit of a trough. It's pretty steep, but then as soon as it gets to the dateline, the jet splits again with some energy pushing, most energy, I'd say, pushing down off of British Columbia, trying to create a little trough there. And what these troughs do, see that dip like right there, that helps create a eddy, a counterclockwise circulation aloft in the atmosphere, but that circulation also translates down at the surface, and that is the hallmark of low pressure. Low pressure, if it's strong enough, generates winds. Winds, as they get traction on the ocean surface, generate seas. Seas, as they radiate away from the fetch area, get groomed and eventually turn into swell, and swell, when it hits your beach, turns into surf. So it all starts with a trough in the upper atmosphere, so that's why we spend a little bit of time looking at that. So we see something here off Japan, we see almost something off of British Columbia, but it's so close to land it really doesn't make hardly any difference, and by Monday it's pushing onshore over Oregon. The trough off of Japan starts cutting off, really not doing anything, and then pretty much nothing as we get into Tuesday. But then as we get into Wednesday, notice the winds, this trough here kind of falls apart, but wind energy still keeps going. It gets reinforced by little energy off Kamchatka and the Kuril Islands and starts falling south, and a little bit of a trough is forecast starting to form on Wednesday, and then pushing through the Gulf into Thursday and into the Pacific Northwest, but yet more energy. Notice the jet, the split jet consolidating here close to the dateline, generating 140 knot winds as we get into Friday, falling south, digging out a deeper trough, and that actually looks like a legitimate system to help support some sort of gale formation. The first one in months that hasn't just like formed right off the coast and come barreling into California. So maybe there is some hope here for some swell development, or at least low pressure development as Saturday as we get into Sunday, the 9th of April. Then that trough still present as we go 180 hours out, so something to watch. Also notice the ridging pattern over California. That would mean high pressure. That would mean some protection from weather, and there is some sense that that's exactly what's going to happen. We'll get into that in a minute. All right, so let's go take a look down at the surface. Surface level pressure, surface level winds. No big surprise here. Pretty quiet pattern. High pressure in control here in the northern Gulf or the northwestern Gulf. Low pressure inland, you get a pressure gradient, you get these winds. Winds circulate clockwise around high pressure. So you see, what's that, 20, 25 knot winds off of Oregon, generating wind swell. Little low pressure off Japan, really not doing anything. We'll put this into motion. So you get into Monday. The low here fades, high pressure falls south, fetch moves over California. We get into the details on that in a minute, but pretty windy situation around the central and North California coast is expected. Continuing into Tuesday and Wednesday. Now notice a little bit of low pressure trying to organize off Japan, nothing aimed at Hawaii, nothing aimed at the U.S. West Coast. And then as we get into Wednesday night, here's where things start getting interesting, because remember, there's a trough starting to dig out here. 40 to 45 knot northwest winds are expected over a small area, fading to, we'll say, 40 knots as we get into Thursday, aimed well at the U.S. West Coast. A little bit of sideband energy maybe for Hawaii. That trough and the associated low pressure starts fading Thursday night into Friday as it pulls up into the Pacific Northwest coast. Another little batch of energy behind that with 30 knot winds falling southeast. So some potential here for the ocean to at least get stirred up a bit, push some energy south and southeast. We'll see exactly how this plays out. Some secondary fetch building, but then here comes high pressure as we get into Sunday, the 9th of April. Oh, but look at that. Yet more energy forecast for the Gulf as we get Well, we'll just take it out to 7 days. So potential, the first semi-real anything that's been on the charts for a month now. So something to look forward to. Let's go look at the effect of those winds on the ocean surface. So here we go. Here's the current state, little low off of Japan, otherwise pretty quiet pattern. Nothing really expected. We're eyeballing the gale in the Gulf later on Wednesday, and as we get into Thursday, those winds get traction. Seas 25.4 feet. These are the highest seas over this entire image or domain, however you want to call it, and aimed pretty well off to the east. So we get into the evening, seas still about 23 feet. Into Friday morning, still barely 19 feet. Secondary energy up here off the North Dateline region with 20-foot seas, and then everything fading into the 17 to 18-foot range on Friday night and fading from there. But you can see some sort of a swell front, if you will call that a weak swell front, or maybe wind swell front or something, pushing into Northern California as we get later into Saturday and Sunday, and then pushing south down the coast from there. Additional fetch theoretically developing up in the Gulf, maybe getting some traction, producing yet more wind swell aimed to the southeast, targeting both Hawaii and the U.S. West Coast. So again, something to look forward to. Oh boy, maybe we're going to get to actually go surfing. Thank goodness. And then a quick look down south. We did have a small swell, I guess it was earlier in the weekend, 1 or 2 feet at 14 seconds, 15 seconds, something like that, but that's all faded out. Looking down south, there is another little gale forecast right here on Wednesday under New Zealand. I mean, this is really small, 27-foot seas briefly. As we get into Thursday sometime, maybe 25-foot seas, aimed off to the northeast pretty well, and then fading out. This has been on the charts for a couple of days now. Was theoretically forecast to have 30-foot seas. Now we're down at 25. Actually, this run, the 18Z run on the model, it actually came up a little bit from what it was this morning. So we'll see about that. That all fades out. I mean, you really need 30-foot seas to get enough energy moving to make the whole 6,000-mile journey to California and, 4,500 nautical miles up to Hawaii, something like that. Now, this new little fetch here, this is new on the charts, wasn't here before. 25-foot seas again aimed off to the northeast. So we'll see. That's a week out, but we're starting to get in the season, so it would not be unexpected. And again, all waters ice-free down here, piles of space to support gale development without being choked by ice. So all we need is low pressure and a little bit of energy, and maybe we'll be in business. Next up, checking winds for California and Hawaii. High pressure dominating the picture in the Gulf of Alaska right now. 1033, 34 millibar high. Winds circulate clockwise around the high. You can see already northwest winds 15 to 20 knots along the California coast. Trades from the east-southeast for Hawaii. Okay for the North Shore. South Shore been a little bit bumpy and kind of warbled lately. As we get into Monday morning, the winds really pick up for California, even down into Southern California. Light trades for Hawaii. So we get into Tuesday, more of the same. Not quite as windy for the California coast. Southern California a bit protected. Trades 15 knots for the Hawaiian Islands. Wednesday, still a lighter wind regime for California. Notice a front trying to push down the coast, lightening things up for Cape Mendocino, while trades build for the Hawaiian Islands at 20 knots. As we get into Thursday, front low pressure starts filling the Gulf of Alaska, so the dividing line somewhere around Point Arena here. I would say northwest winds pretty light for the bottom half of Northern California, all of Central California. Trades for the Hawaiian Islands. Friday, same sort of pattern. Look at the low pressure moving dangerously close to the coast, but the winds look okay from about, we'll say, Bodega Bay southward. No south wind mess until you get up really into Cape Mendocino. Trades for the Hawaiian Islands. Saturday, light wind regime shuts up, light trades for the Hawaiian Islands. And then on Sunday, more low pressure theoretically in the Gulf, light winds for California, protective high pressure and a ridge over the coast, and trades a little bit more east-northeast for the Hawaiian Islands. Surf forecast for Northern California. We're doing it for Half Moon Bay. Surf pretty much small and non-existent. Till low pressure in the Gulf of Alaska theoretically generates some surf, theoretically in the 8-foot range. Right here, swell 6 to 7 feet at 12, 13 seconds, something like that. So maybe a little bit of hope as we get into, this is for Saturday of next week. Looking at the protected bank breaks of Santa Barbara, well, pretty much nothing. Surf, we'll call it 1 foot or less. Looking for swell, 1 feet at 6 seconds. A little bit of energy, half a foot at 10 seconds, something like that. So really nothing there. San Diego, pretty much the same situation, just waiting for southern hemiswell. Right now, nothing in the pipeline. Pure swell size, well, 2 or 3 feet or 1 foot, wherever you're looking. 5 to 6 to 8 seconds, or maybe 1 foot at 16 seconds. So really not a whole lot. And then the North Shore of Oahu, well, really nothing until we get later in the week. That same bit of energy in the Gulf of Alaska, theoretically to produce surf in the 3-foot range, something like that. Pure swell, 2.4, 2.5 feet at 11 to 12 to 13 seconds, something like that for the weekend, maybe into starting Friday later this week. So a little bit of something to look forward to for just about everyone. And yes, we're still looking at snow and precipitation. We're focusing here on California. As of right now, theoretically, it should be raining per the model up in Northern California. And then through the evening, that falling apart. A little bit of snow for the mountains, but not a whole lot in the Sierra. Continuing into Monday and Monday evening, and then pretty much fading out. You can just see high pressure here, driving the circulation, driving everything up and over and then down, the typical backdoor front sort of thing. So we get into Tuesday, maybe a little bit more rain for Northern California, and again later Wednesday into Thursday. But look at this, it just won't get much further south than we'll say Point Arena or maybe Bodega Bay, something like that. Even continuing into Friday as that local weather system approaches the coast. Can't get south of the Golden Gate. No snow for the mountains. And then things really start changing after that. Yes, you get low pressure in the Gulf, but just nothing can penetrate into California. The snow forecast dashboard for Olympic Valley, you can see it here, maybe 6 or 7 inches all in the next 24 to 48 hours, then literally nothing after that. We're not even going to go look at any other resorts. In the Lake Tahoe region, they're all about in the same boat. And to Kirkwood, a little bit less, and Mammoth, even less than that. Here is the real teller on what's going on. So this is the base of Olympic Valley at about 6,200 feet. This is the summit up at the top of Palisades at about 9,000 feet. Red is liquid precipitation above freezing temperatures. The gray represents the 37 down to 32 degree line, which is basically slush. Sorry, 35 degree line. Then white is the freezing right here at the interface between the gray and the white. That's the freeze line. You can see the snow level, if there were precipitation, starting about 5,200 feet, dipping down pretty low at times to below, we'll say 2,000 feet through the night of the 4th. But then after that, you can just see this big warm-up coming. The freeze level going up to 12,500 feet for a few days here as we get April 8th into the 9th and maybe a bit beyond that. Typical springtime warm-up, not unexpected, but with still, as of a few days ago, there was still measurable snow on the ground in the Tahoe area down to about 3,400 feet. With this heat hitting that, a lot of melt and a lot of runoff might be expected. We'll have to see how long this lasts for and how bulletproof of a high pressure system, warm high pressure gets set up over the coast. But we'll keep our eyes out for flooding potential from snowmelt. Let's go take a look long-term now. What's going on with the Madden Julian Oscillation, the MJO, and the El Nino Southern Oscillation, ENSO? These are the two major influences of weather over the Pacific Basin, looking out anywhere from a month to 2 years out. You can get a pretty good idea of how things are going to play out by following these oscillations. So we're going to dive into the details there. So we'll start talking about the MJO, the Madden Julian Oscillation. There's two phases to the MJO, active phase and inactive phase. And what is the MJO? Well, basically, it's a low pressure system or a high pressure system. The active phase is a low pressure system. The inactive phase is high pressure. They rotate on either sides of the planet, around the planet, going from west to east on the equator. Active phase on one side of the planet, inactive phase on the other. When the active phase starts moving over the West Pacific, because it's low pressure, it takes warm, moist air, starts pumping it up into the atmosphere. That gets caught by the jet stream. It energizes the jet stream, starts digging out troughs, helps make the jet stream consolidate instead of being split, and then that can help form storms. Also, when the active phase is in the far West Pacific, it actually dampens trade winds. If it's strong enough, it can actually reverse trade winds there. And what happens is in the equatorial West Pacific, when the active phase is there, and if it's strong enough, with the reversal of the trade winds, that pushes warm water that's normally piled up there by the trades, starts pushing it east, down in the ocean along the thermocline, creating a thing known as a Kelvin wave. If you eventually that Kelvin wave, which is just a ball of warm water, travels from west to east across the Pacific, takes about, we'll say, 3 months, eventually will erupt on the coast of off of Ecuador and the Galapagos, creating a warm water slick there. If you get successive active phases of the MJO, you get successive Kelvin waves, that warm water starts building up off of Ecuador, and you start getting a lot of evaporation. That changes the upper level circulation and helps usher in El Nino. And of course, El Nino is great for producing storms in the Pacific, big surf, snow and rain into California, and generally helps bust up drought. Now, the opposite thing also happens with the inactive phase. Because it's high pressure, it feeds trade winds. You get cold upwelling off the Galapagos, and that can be, if you get successive inactive phases or a dominance of the inactive phase, that ushers in La Nina. If you have successive active phases of the MJO and they keep going, that helps usher in El Nino. All right, so we're looking for any signs of slackening trades across the Pacific. This is data from the TAO buoy array, series of buoys strung across the equator, used for monitoring El Nino. There's wind sensors on there. We're just looking at the arrows. This is from those wind sensors. The longer the arrow, the stronger the wind. So moderately strong east trades in the East Pacific, moderately strong east trades over the Central Pacific, moderately strong trades in the West Pacific. Oh yeah, and here's the equator. There's the date line there. That's New Guinea right there. But it's not the actual wind speeds or even the average wind speeds, which this is 5-day average wind. So they're not like those buoys off the coast we use for monitoring surf. This is more sort of a longer-term generalized view of the world. But it's the anomalies. Are these winds stronger or weaker out of the east or the west, considering what time of year it is? Well, in the East Pacific, the winds are, well, a little bit more out of the east, but also a little bit more out of the west, so kind of a mixed bag. We'll say maybe just a little bit stronger out of the east than normal. Central Pacific, just a little bit stronger out of the east than normal. In the West Pacific, about the same deal. So neither the active phase or the inactive phase, just looking at this data, but this data is pretty raw and kind of hard to tell. Let's go dig a little deeper. Here's the wind anomalies for the whole planet for the past, 5 days. There's 5 different panels here. So the oranges are westerly anomalies, wind blowing out of the west. The blues, and you can see the arrows just barely here, easterly anomalies. South America, Central America, Hawaii there, New Guinea right there, the equator right there, dateline here. What we really want to see is the active phase over the West Pacific. We call it the Kelvin wave generation area, from 170 west the whole way into about somewhere in here about 125 east, and just 5 degrees north and south of the equator. So as of March 27th, it was mainly easterly anomalies. Same deal on the 28th. 29th, well, maybe a couple little westerly anomalies, a westerly anomaly pattern starting to build on the 30th, and a little bit broader on the 31st, but also a little bit of easterly anomalies here, so kind of a mixed bag. Let's go look at the forecast for the next week. Here's the forecast: zonal wind anomalies, 850 millibar zonal wind anomalies. That's a mouthful. What's that mean? Well, 850 millibars is how high in the atmosphere. They don't do it by feet. They do it by pressure levels. But 850 millibars is about 4,700 feet up, which is a pretty good proxy for what's going on at the surface. All right, so this is the whole planet. The oranges and reds are westerly anomalies, so winds, those would be the ones we want to see, like the active phase of the MJO. And you can actually see that here. Oh, in fact, let's get oriented. Dateline right there. So the West Pacific starts about 125 east, so right there. And the far East Pacific, Ecuador, about 80 west, so right around there. So you can see westerly anomalies in the early part of March pushed across the Pacific, probably associated, well, definitely associated with the active phase of the MJO, and pretty strong south of California. So where these westerly anomalies are and the peak of them, north and south, and this is just on the equator, but north and south of that, that's where the weather is. Likewise, the blues are easterly anomalies, strong enhanced trades. That's what's still in control. And it looks like the inactive phase of the MJO, the latter half of March, working its way across the Pacific and still in control. Its last little gasp probably, this is just out a week, so we'll say 5 to 7 days from now. But notice, westerly anomalies already building to about 140 east. So what's that? About 25% of the way across the what we call the Kelvin wave generation area, and building pretty strong 5 days from now. So it looks like inactive phase of the MJO is covering the dateline right now. I'm going to hang for another week, but the active phase building directly behind it and already influencing the far West Pacific. Another component of the MJO is cloud cover. Yeah, active phase of the MJO, if it's low pressure, well, typically you have clouds associated with low pressure. The inactive phase, if it's high pressure, typically you would associate that with clear, cloudless skies. So this is just a model of cloud cover. The blue suggests more clouds than normal, less sunlight reflecting off the ocean surface. That's really what this is, outgoing long wave radiation, just sunlight bouncing off the ocean. But if you have a bunch of clouds over top of it, you're not going to get more reflection off the ocean surface. So that would be active phase of the MJO. And where are we? Well, there's South America, Central America, Hawaii, New Guinea there, dateline right there, the equator right there, Kelvin wave generation area right in here. So looks like the active phase of the MJO. And so now, let's be clear, the MJO, there's different ways it's established, but typically the cloud cover comes first, the westerly anomalies come behind it. So this is an early indicator of clouds building over the Kelvin wave generation area. Forecast holding 5 days from now, 10 days from now, and 15 days from now, the active phase of the MJO for the next 2 weeks. This is per the statistic model. The dynamic model pretty much showing the same thing, but the active phase maybe not as strong initially, but building more in the later 2 weeks from now, in the later part of this model run. So either way, they're in sync, suggesting some sort of mild active phase of the MJO in control and building. All right, phase diagrams. This is another amplification of the two models we just saw, statistic model and the dynamic model. Now, how do you read this? Well, the MJO moves from east to west around the planet, from the Indian Ocean to the Maritime Continent, over the West Pacific to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot is where the active phase is right now. So according to the statistic model, it's right on the verge of being in the West Pacific. Now, if the dot is inside this circle or on the circle or close to it, it's very weak. These are 3 projected paths here. So either way, active phase, very weak in the West Pacific, moving to the East Pacific over the next 2 weeks. The dynamic model suggests, well, the active phase moving almost to the East Pacific and then backtracking to the West Pacific and stalling 2 weeks from now. And this model seems to have a better handle on things than this one does. And it forecasts this thing where it just like cut off the maritime continent, moved into the West Pacific way before the statistic model did. So we'll put a little bit more weight in this. It looks like perhaps a moderate hangout of the active phase over the West Pacific. That's exactly what we want because, again, it's going to impart energy to the jet stream, and that might help give us some surf. The upper level model giving us yet another view of something different, cloud cover. Okay, I'm sorry, precipitation. The last model did the one before did cloud cover. Now this is precipitation associated with those clouds. Green is clouds and precipitation. Orange is in red, dry air. All right, and this goes out 40 days, 5 days a panel, South America, Central America, New Guinea there. The equator right there, the date line roughly there, Kelvin wave generation area right in here. We're very interested in production of Kelvin waves because, again, that is what feeds El Nino. So we have wet air over the Kelvin wave generation area. Because this is up in the jet stream level, it's about 5 days to 7 days ahead of what actually happens at the surface. But this suggests that the active phase is building over the West Pacific. It's to make its way through the Kelvin wave generation area through about mid-April, April 17th, then pushing into New Guinea through the end of April and out of there, with the inactive phase coming in behind it starting, we'll say April 27th, and then continuing through the end of the model run, we'll say mid-May. All right, so here's where things get interesting now. This is a model, east-west component of the wind, going out a month from April 1st to the end of April. This is the east-west component of the wind, so the reds are westerly anomalies, the blues easterly anomalies, and you can actually see, like up here, this is back in early February, solid contours, the active phase of the MJO, and this is going the whole way around the planet from, well, 0 is like England, the whole way from there across the Pacific, across the Atlantic, and then all the way back to England over a period from, what was that, we'll say January 27th through March 22nd, something like that. So a whole month, the whole way around the planet. And look at the westerly anomalies that were associated with it as it ventured around the planet. Likewise, the dotted contour is the inactive phase. Our last big inactive phase is back in early February. After that, the dam pretty much broke. Major active phase of the MJO. We're currently now in, well, here's today, April. Well, this is run on April 1st, and this is no joke here. This is real. We're not pulling your leg here. The inactive phase of the MJO, weakly in control the Kelvin wave generation area. West Pacific starts right about there at 125 east. Dateline right there. Kelvin wave generation area ends right there about 170 west. So inactive phase of the MJO, theoretically in control for about 2.5 more weeks. But notice the active phase right there with it, with strong westerly anomalies already starting to set up about a week from now. That tick mark is a week. Strong westerly anomalies in the far West Pacific and just hanging and slowly plodding their way almost to the date line. And at the end of the model run, April 29th, west anomalies completely filling almost the entirety of the Pacific Ocean. If that isn't a red signal that some major sort of change is occurring, well, then I don't know what is. But let's dig yet one more chart deeper. So here's the CFS model going out 3 months. All right, now past performance is down here, future performance is here. Oranges and reds, westerly anomalies. The blues, easterly anomalies. The easterly anomalies, the La Nina signal, you can see come about February 15th. Something really changed. Active phase, westerly anomalies pushed across the Pacific. Oh, and here's the date line right here. Far East Pacific, 125 West Pacific right here. Okay, Kelvin wave generation area. Looking at this is the forecast up here. So really our area of interest is from here over to about here, Kelvin wave generation area. You can see our little inactive phase of the MJO producing easterly anomalies in control of the dateline region right now, but come about a week from now, the easterly anomalies fade. Here is our building active phase of the MJO, but what really gets your attention, when you see a bright red blob like that, that's what they call a westerly wind burst. That's not just the anomalies of the westerly winds being lighter than normal, allowing a little bit of warm water to slosh across the Pacific in the form of a Kelvin wave. This would be an out-and-out westerly wind burst where the winds literally change direction over a good area, well, from the beginning of the far west Pacific the whole way to the dateline. That's 1,500 miles, 2,000 nautical miles of westerly winds blowing. That would create a major Kelvin wave. And what's even more interesting is you look, westerly anomalies fade a little bit in May, and then boom, they're right back in action the whole month of June. So this smells of major MJO activity, typically associated with the formation of El Nino. So let's overlay the MJO. Dotted contour, inactive phase of the MJO. We know that's what's happening now. We're already past the peak of it. It's only got about a week more to go. Then it's active phase, some sort of nondescript something, followed by another active phase, followed by a weak inactive phase, and then another active phase behind that. But again, it's this just westerly from April, we'll be conservative here. We'll say April 10th or April 12th. From then on, just nonstop westerly anomalies. So what's driving all this? Let's overlay the low pass filter. This makes it real obvious. The dotted contour here, in fact, we can even take the MJO out of it. That makes it easier to read. The dotted contour is like a high pressure bias. It doesn't mean high pressure per se, but a tendency for high pressure to persist. And well, there's the dateline, and this is the La Nina indicator, which is basically high pressure locked over the dateline. Well, notice it's on the move, moving east of the dateline and completely east of the dateline by about mid-April and fading from there. And what do we have here? This is the El Nino indicator, the low pressure bias, which has been locked over the maritime continent for 3 years now, or 2.5 years. It is fully on the move, pushing deeper. Where is it today? Probably about, I think it's about 150 east, so about halfway across the Kelvin wave generation area. And in the next month or so, filling the whole area from the dateline and even more so into the Pacific. That's what's driving these westerly anomalies. So you have the low pressure bias combined with the active phase of the MJO, and notice you go from one contour here to 2 to 3 to 4 contours. That's a very deeply embedded low pressure bias right over the dateline, and we're only in the beginning of summer when this all sets up. I can't imagine what's going to be happening come fall and winter. Typically El Nino peaks in the somewhere between Thanksgiving and Christmas, somewhere in that time frame. And even when it starts to fade, you still have a year of repercussions after that. So this looks like some sort of major El Nino trying to get established. All right, so what's going on in the ocean? This is a three-dimensional chessboard that we're playing with here. You have the atmosphere, you have the ocean surface, you have down in the ocean. They all have to be in a line. They all have to be moving the same way to either have El Nino or La Nina. Right now, I think officially we're not La Nina anymore, but there are still components of La Nina in the atmosphere, It's a big boat. It doesn't turn all at once. So the jet stream and all that sort of stuff, it's been moving and predisposed to a certain pattern now for 3 years. So it's not just going to shut down on a dime. But clearly something's going on with the active phase of the MJO and the low pressure bias. And it's all moving into the Pacific. Does the ocean sense what's going on? Well, clearly the answer is yes. So this is data from the TAO buoy array. Again, this is the East Pacific. This is the West Pacific. We're just looking 2 degrees north and south on the equator, but they've strung some buoys out there. These are the anchor lines on those buoys strung the whole way across the Pacific. The X's are sensors on the anchor lines. They read temperature data in centigrade and then use a model to fill in the gaps. And you can see, well, is all the warm water pushed up over in the far West Pacific, or is it starting to slosh to the east? Are we getting Kelvin waves? Okay. So we look at the 29-degree isotherm, 29 degrees centigrade. That's very warm water. Last week is at 165. 2 weeks before that, it wasn't even on the chart. Now it's moved to 167, almost 168 east. So warm water on the move at that level. The 28-degree isotherm, it's been locked at around 180, something like that. It looks like it's at 178 west, so it's moving. The 26-degree isotherm, well, it was stuck at 140 for 3 years, and about a month ago it broke loose, pushing the whole way into Ecuador, is driven by a Kelvin wave, warm water moving off the east. And now there's 28-degree isotherm, or 28-degree temperatures even filling the far east Pacific. So a lot of warm water is already on the move. It's not actual temperatures that matter. It's the anomalies, difference from normal for this time of year. And the picture is even better there. 3 degrees centigrade anomalies. This is a massive pool of warm water. Is pushing to, we'll say, roughly, what's that, about 130, 135 east. A previous Kelvin wave and warm water from that sitting off of Ecuador, filling that area. There is literally no cold water to be found, no break. All this suggests is an ocean of warm water has moved and is in movement to the East Pacific. This is typical La Nina formation sort of scenario. But what's not typical is you typically don't see it in late March and early April. This would be more like a June, July sort of time frame. So this suggests that this El Nino is really got a lot of momentum behind it and is happening earlier than is typical for any El Nino development. Another model, same sort of thing, a different technology, but it's painting the exact same picture. 1 Kelvin wave sitting here erupting off of Ecuador. Kelvin wave number 2 right here. Its leading edge at 120 west right there. So that's due south of California. Kelvin wave number 3 down here bleeding into the Pacific from the maritime continent from yet another westerly wind burst associated with yet another active phase of the MJO. So 1, 2, 3 Kelvin waves in a row, all in flight, just cooking subsurface temperatures. Now, notice, temperatures here are warm. Temperatures get real warm, they fall down, they kind of lose some of their mojo, but then as they start rising up in the thermocline, and I can't explain why this happens, but all I know is temperatures get much warmer as they get into this area and really start blooming as they erupt along the Galapagos and Ecuador. So this is the technology that drove that previous model. The images of the subsurface temperatures before that were actual sensors on anchor lines. This is satellite based. Okay, you take a satellite, run it over a polar orbit over the north and south poles, beam down radar, strip out, and you get the height of the sphere of the ocean. Strip out the waves, the wind waves, the tides. Is the sphere of the ocean higher or lower than normal? Across the ocean, where it's higher than normal, so this is the equator here. In fact, let's go Chile, Peru, Ecuador, Hawaii is right there, equator there, date line there, New Guinea there. Oranges and reds, higher than normal. Why? Well, warm water at depth expands. When it expands, it displaces water above it up. So the ocean surface rises just a couple of centimeters, but that's all you need. 5 centimeters, 10, maybe 20 or 25 down here. But you can see, and colder water contracts, it'll create a divot on the ocean surface and get these negative anomalies like here. Now, what we've had for 3 years is negative anomalies all in here. That's all but gone now. Still, lots of warm water bleeding up through the maritime continent, driven by the active phase of the MJO, creating west winds. That warm water, you can see it just pushing right along the equator. This is Kelvin wave, leading edge of Kelvin wave number 1, the beginning of Kelvin wave number 2. Kelvin wave 1 here, impacting the coast, displacing north and south. Eventually that warm water will start leaching up into Mexico and even up into southern northern California and likewise down in Chile. So 1 Kelvin wave impacting, a second making its way across the Pacific, a third likely forming out here. This is all very good news. Upper ocean heat anomalies, just another visualization of the same data. This is the West Pacific here, East Pacific here. Oranges and reds, warmer than normal temperatures, blue, colder than normal temperatures. Here is our La Nina fade out in, well, it tried to fade. It got a Kelvin wave impacting it back in June, July, but there was no Kelvin wave after that. La Nina became reestablished, trade started nuking, massive upwelling. Another weak Kelvin wave in December, but then January, another Kelvin wave, and this is Kelvin wave number 1, which is already impacting. Here's Kelvin wave number 2. Look at this just massive displacement of warm water, pushing to almost, we'll say 125 west, so that's due south of Southern California, and continuing its push off to the east. Now, it is a little bit concerning here. You see these really dark, warm waters here. With this Kelvin wave, some of this heat has been discharged. The expectation is that with more active phases of the MJO and more westerly anomalies, warm water from the maritime continent will get flooded or pushed into this area, but we'll keep our eyes out for that. Not a major concern at this moment. Next up, sea surface temperature anomalies. So we talked about the MJO and winds. We talked about down in the ocean and what's happening with Kelvin waves and warm water displacement there. But ultimately, it's what's happening at the surface that really matters, because it is evaporation that drives the upper level circulation. So you have to have warm water on the ocean surface, creating evaporation uplift, and that in turn affects the jet stream and affects everything else and changes the circulation of the weather around the planet. All right, so where are we? Chile, Peru, Ecuador, Central America, Hawaii out there, the equator roughly here. You can see lots of warm water off of Peru and Ecuador here. Now this is normally where you have offshore winds and you have lots of upwelling, and when you get that upwelling pattern here off of Peru, nutrient-rich water rises to the surface, the fishing industry goes nuts. But when you get very warm water, it does the exact opposite. It's downwelling, if anything. Now, you also see trades, they're blowing this way here. They're taking this warm water. This is the result of the Kelvin wave impacting this area, right? Trades will take that warm water and start dragging it across the equator, just like we see here. Those warm waters are out to about 145 west right now. The last little bit of the La Nina cool pool is hanging right around here, but pretty much inconsequential at this moment. Now, the last little bits of La Nina still in the atmosphere driving high pressure. Get that upwelling pattern, northwest winds along the north and central California coast, even down into Baja. So we're in this mixed mode, right? The last little bit of La Nina driving the spring upwelling pattern, while at the same time down on the equator, completely blind to what's happening here. El Nino driven Kelvin waves are impacting the coast, creating warm upwelling. There is a battle probably going on in the atmosphere at this very moment upon, well, am I La Nina or am I El Nino? We're somewhere in the middle right now, but the trend seems definitely weighted in favor of El Nino developing. Sea surface temperature trend for the past 7 days. Well, we had a lot of warming going on, but that all is, you notice we have, and it's just on the equator, 5 degrees north and south of the equator over the whole Pacific basin. That's what matters. We see warming generally out here south of Hawaii, but this little area from about 120 west right in here where we know all that upwelling is going on. You can see it directly along the coast of Peru here, but right in here, we want to see this starting to warm. That's the classic El Nino kind of thing. It is not warming at the minute. I think we know why. Inactive phase of the MJO in control. It's probably driving trades a bit harder than normal. Yeah, there's piles of warm water down in the ocean, but as soon as it hits the surface, it gets mixed by stronger than normal easterly trades, and you get this kind of muddled, mixed, it's warming, it's not warming, it's warming kind of pattern. Well, we think give it about a week or two. As the active phase builds over the Pacific, that'll all shut down. You'll see this starting to light up again. Now, that last image was just the 7-day trend. Here's actual water temperatures. I mean, no doubt about it. It's getting warm and very warm, but it's this area right in here. We want to see that starting to really light up. Wouldn't expect that normally until October or something, but just given the magnitude of how much warm water is in motion, it seems like this should be lighting up here any week now. Sea surface temperature index in the Nino 1.2 region. So this is the area right there along Ecuador and Peru. You can see temperatures just heading up 2 degrees above normal. 2 degrees and 57 thousandths of a degree above normal. If you're in the official El Nino monitoring region, well, it's either half a degree above or below normal is considered neutral. Anything above that is El Nino. Clearly, we're in that territory, but this is not the official El Nino monitoring region. This is the Nino 3.4 index, and this is the area from south of California out to about the dateline on the equator. Temperatures there, 117 thousandths of a degree below normal. Been sitting that way for 1 to about 3 weeks, something like that. So basically neutral, neither colder, La Nina, there's a half degree below, or warm enough to be El Nino. And when I said earlier that we're kind of in this in-between state, that's exactly where we are. Yeah, lots of warm water building off of Ecuador, but it hasn't moved west into the official El Nino monitoring region. The other thing, though, one could say is, well, if you get enough warm water over here, that is very indicative of a strong easterly based El Nino, and that's what you want. It's not these westerly based Modoki El Nino sort of things where they just sort of gurgle out south of Hawaii but never really make it into Ecuador. You want this is clearly signaling lots of lots of warm water building off of Ecuador. That's what you want to steer the jet stream into California in winter months. We're not saying that's going to happen, this spring, but come next fall, next winter, if this keeps going, eventually this is going to follow, and then we could be in for a bit of weather as we get into later next fall. So we did this last week. We'll do it again this week. We're going to go back in time, March 31st, 1997. Okay, 97 was the last. It was a super El Nino, and we went last week, and you can go look at the video, compared water temperatures for all the past recent El Ninos somewhere after 82, I think it started in 85, and this was the strongest signature we found in March, and that's what it was, just a little bit of warming, and this turned into a super El Nino. This was a major big El Nino, months and months of just pounding surf and rain and weather and snow and you name it in California, and huge surf in Hawaii as well. So this was the signature basically today back in 97. Now we're going to compare, and I'll move myself out of the way down here. Okay, so here's where we were January 1st of this year, and we're just going to go week by week by week, and you can look at the evolution of water temperatures down here. January 8th still, in the blue, colder than, we're going to just go back. Colder than normal temperatures. This is the classic La Nina signature. High pressure above it, cold temperatures, no evaporation. January 8th, January 15th. And notice warming starting to build, a little bit of cooling along Peru, but notice the beginning of the warm signal as we got into January 22nd. By January 29th, wow, look at this. I mean, just boom, it just blows up come the 5th, the 12th, the 19th of February, the 26th of February. Now, you get these little winds that blow through the channel here and create upwelling, and so you get a little bit of a cold signature there. But then we got into March 5th, that wind event was over, and then here we are, March 12th. Look at how much warming has happened in just like a month. And then we go to the 19th, and then we go to the 26th of March, and I think we have one more here. There we go. So you see, much warmer than normal. Now we're going to compare that to, that's where we were March 31st of 97. And that's where we are now. So much warmer this developing El Nino than the last biggest El Nino almost on record. So something to be mindful of. All right, so what's going on in the atmosphere? We talked subsurface, Kelvin waves galore, warm water moving off to the east. We talked the ocean surface, warm water building along Ecuador and Peru. Not quite as strong as they were maybe 2 weeks ago, but still a building pattern. What's happening in the atmosphere? All right, well, we look at the Southern Oscillation Index. Difference in pressure between Darwin, roughly in the Indian Ocean, Tahiti in the Pacific Ocean. When pressure is lower in Tahiti, the index goes negative. When pressure is higher in Tahiti, the index goes positive. We've had 3 years of positive readings, but now look. Daily index minus 19, and we go back. Hey, wait a minute, look at this. Almost everything is negative here back till about March 11th. I don't remember, it was like 18 or 20 days of almost continuous negative readings now. Okay, this is a dramatic change, and we talked about this the past couple of videos. We knew that this change was coming. It clearly is happening now. Now, this is daily data, a lot of noise there. So we'll just go to the 30-day average. It sort of, smooths out some of the bumps, minus 3.8. Today, we're at minus 19.4, right? The 30-day average, minus 3.8. And what's it been doing? Well, we were at 9.95 a month ago. Now we're down into negative digits. This is at least a sign of the active phase of the MJO. And the 90-day average, well, today we're still positive, 5.56, but where were we? Well, 13.1 a month ago, steadily heading down. This is all exactly what we would expect to see. Now, this is a lagging indicator, okay? It's almost a month behind what's happening on the ocean surface, but still, this is confirmation that changes are happening in the atmosphere, as we can see here, happening on the ocean surface and subsurface. And we know there's more active phase, significant active phase of the MJO activity scheduled over the next 3 months. Everything appears to be in line. The pendulum is swinging back into the Pacific in a good way. Here's the 30-day moving SOI graphed out. Again, when you're in La Nina, inactive phases of the MJO take precedence. The index goes up, as you can see here. April 21st was July 2021. This was the last time we were in neutral territory. It's been steadily upwards from there. These are the inactive phases. The upward spikes are the inactive phase of the MJO. The downward spikes are the active phase of the MJO. When the inactive phases of the MJO outweigh or outnumber the active phases, then you get this upward trend. But look at what is happening here. We're just falling. The bottom is dropped out. Just a long running 1, 2, 3 active phases of the MJO. Now still, notice the zero line is here. We were up at plus 20, plus 25. This has to go down to minus 20 or minus 25, but at least atmospherically, according to this, we are in neutral territory for the first time in years. This is a good sign. We think we're still heading down from there. And finally, sea surface temperature forecast in the Nino 3.4 region, the official El Nino monitoring region from the CFS version 2 model. Today, oh, and right there's 0 degrees. Positive is up here, negative is down here. Here was our La Nina indicator, -1 degree for forever. Today, April 1st, dead neutral. Temperatures, of course, this is the raw uncorrected data. By July, going to 1.2 degrees, maybe 1.15. And by October, November, up to 2 degrees. That would be in significant El Nino territory. Now, that's the raw data. The PDF corrected data, probably a little bit closer to the truth, has temperatures going to about 3/4 of I don't know, even more than that, 0.85 a degree by July. So that would be in El Nino, fully in El Nino territory. And then moving up to 1.6 or 1.65 degrees as we get into November. That, honestly, given where we're at, seems a little bit on the low side. But either way, both versions of this model indicating some sort of El Nino coming. So for right now, hey, it actually looks like maybe we're going to get some surf. Low pressure forecast for the Gulf of Alaska, seas building, aimed pretty well at the U.S. West Coast, maybe sideband energy for Hawaii. And then even after that, maybe some secondary energy with more swell production. It's about time. It's been 6 weeks of almost nothing. So here we go. Maybe it's time to wake up and get ready to go surfing again. Likewise, the snow forecast just looks like it's drying up. A lot warmer temperatures coming. It's springtime. It's beach weather. Let's all go to the beach. Anyway, looking longer term, El Nino development still seems highly likely. Massive amounts of water moving over the equator, heading for Ecuador. Massive upwelling event expected there. All this will only help fuel El Nino development. The SOI index now indicating that the atmosphere is at least neutral, starting to turn towards El Nino-ish. Now, of course, you're not going to see any real signs of that in the spring or even this summer. Maybe later in the summer, the southern hemisphere might wake up a little bit and start responding. Still, we have quite a ways to go before we're in a literal El Nino type situation, but definitely the trend is moving in the right direction. All right. Thank you for watching our video. Be sure and like, give us a thumbs up, subscribe. If you have comments or questions, write them up down below. We'll be happy to answer them. If you're thinking it, 10 other people are as well. And if you want to give us a little donation, that'd be fine too. We're trying to get a new server to support our buoy information. We're getting pretty close as of now. All right. That's it for this week. We'll do it again next week. Same time, same channel. Thanks for watching.